I am Dr. Binu. In IoT Concepts and Applications, the fifth module of the first unit is fog computing. Fog computing is nothing but in order to provide the solution for the challenges of IoT is to distribute data management throughout the IoT system. Real life example of fog computing is an embedded application on a production line where the temperature sensor is connected to the edge server would measure the temperature in every second. This temperature data would be forwarded to the cloud application for monitoring the temperature. The concept of fog was first developed by Flavio Bonomi and Rodolfo Miltano of Cisco Systems. Advantages of the fog system is the fog node allows intelligent gathering and control from the closest possible point. Other advantages of fog computing is it provides low latency. There is no problem with bandwidth. Due to many interconnected channels, loss of connection is impossible. High security, improved user experience, power efficiency. Some of the drawbacks of IoT is IoT in fog computing is fog is an additional layer in a more complex system. It provides some additional expenses because of edge devices like routers, hubs, gateways. Limited scalability. This fog is not scalable like a cloud. This particular diagram depicts the concept of fog computing. The next subdivision is edge computing. Edge computing is nothing but fog computing solutions are being adapted by many industries. The natural place for a fog node is in the network device that sits closest to the IoT endpoints. These nodes are typically spread throughout an IoT network. In recent years, the concept of IoT computing has been pushed even further to the edge, and some cases now resides directly in the sensors and IoT devices. Edge computing is also sometimes referred as mist computing. If clouds exist in the sky, the fog sits near the ground, then mist is what actually sits off the ground. New classes of IoT endpoints have enough to compute the capabilities to perform at least low-level analytics and filtering to make basic decisions. Some of the examples of edge computing is one example is smart meters. Edge compute capable meters are able to communicate with each other to share information on small subset of the electrical distribution grid to monitor localized power quality and consumption. They can inform fog node of events that may pertain to only tiny sections of the grid. Models of this provides highest quality of power delivery to the customers. Another example for edge computing is water sensor on a fire hydrant. While a fog node is sitting on an electrical pole in the distribution network, we have an excellent view of the fire hydrant in local network. A node of each hydrant would have a clear view of a water pressure drop on its own line. It would be able to quickly generate an alert of the localized problem. This particular diagram depicts the concept of edge layer, fog computing as well as cloud computing. The latency is high in the cloud layer, which reduces to the edge layer. cloud computing, the delivery of on-demand computing services is known as cloud computing. The cloud computing can be provided by means of three services: infrastructure as a service, platform as a service, software as a service. Advantages of cloud for IoT is the performance are very high, storage capacity is high, processing capabilities are very good, cost is very less. Some of the disadvantages of IoT are high latency, downtimes, security and privacy.